Hey PCWorld fans, Adam here with Travis from Dell. Please, Travis, introduce yourself. Tell the fine folks what you do.
Thank you. Hi, my name is Travis North. I work in the office of the CTO, and my expertise is power and cooling. And hopefully we're here today to talk about a little bit of new technology that we've enabled.
Yeah, and actually you had a previous interview with Gordon. It was a whole series going over the thermal limitations for laptops and cooling designs and things like that. And I'll tell you what, there were a lot of comments who said, this guy doesn't know what he's talking about. First off, do you know what you're talking about?
I hope. I've been doing this long enough that if I don't, I think I shouldn't be employed, but yes.
Okay, and how long have you been
at Dell for 20 years, and so It's been 2 decades. Actually, this February 15th will be my 2nd decade.
Oh, okay, awesome. So yeah, okay, listen, you understand cooling, you understand the thermal design, all that kind of stuff. To tell you the truth, my knowledge is much lower than you, so you're gonna have to explain some of this to me like I'm like
Do you put a quilt on your bed when you sleep at night in the cold weather? That's all thermal, so we could talk about this pretty easily.
Okay, all right, well I want to start off with a little high level, because obviously right now in a lot of laptop designs, you have fans. Everyone's familiar with these thin little fans that that sometimes make a really high noise, things like that. Is this the future? Like, do you think that at some point no laptops will ever have fans?
I think noise at Dell, we've been on a journey since 2020 to really reduce the noise and give a good experience, right? You see fanless products, so everybody wants to get to the point where the noise isn't impacting my daily productivity. Whatever am I doing? Am I gaming? Am I doing content creation? Am I answering email? I want it where it's not distracting. It takes me out of my workflow.
Yeah.
And so at Dell, yes, we've been on a mission to try to reduce noise, and across almost all of our product lines, this has happened over time. And the technology we're actually going to talk about today is that next evolution of where we hope we're going, which is silent cooling.
So yeah, that's the thing, is that the PC technology is always moving forward, right? Yep. And there's always innovations, and I feel like, the fan, it's been around for such a long time. It's such a basic thing. Why are we still using these?
Well, fan technology, it has its purposes, and that's why it's so well done. Mm-hmm. You've got a mechanical blade that's rotating. That rotating blade has lift and it has drag, and it basically imparts momentum to the airflow around it. The challenge with it is it creates a sound wave, which is noise. And so from that, you're really looking for a technology that, can I get rid of the blades? Can I get rid of the rotating media? And then you have an opportunity to really attack the noise spectrum, lower the acoustics, and get to a point where you're having all that compute without hearing the noise.
Okay, yeah, and so you at Dell have been looking at different kinds of technologies to kind of get away from the old stodgy fans kind of stuff.
Absolutely.
Yeah, and one of them specifically is here today. It's you've partnered with a company called Ventiva. So you've got a nice little demo going on here. Please tell me what we're looking at.
And so this is basically the Dell Pro system that we have retrofitted as a proof of concept. And the illustration is really what we talked about. How can I get to silent productivity? How can I get to that point where I'm giving you that full system performance without the noise? So this partnership was with Intel and Ventiva, and we really attacked this problem by going back to fundamentals. And part of the technologies that made the most sense was basically what they call coulombic cooling. So it's basically charges to pull those charges through basically a media and create flow through the system. So what you see here is from VTV is their Ice Engine. This is their ionic cooling engine, shown in 3 locations. So unlike a traditional fan, which you see this outer box, which we used previously, we were able to remove that device, use a much more compact system, and basically impart flow to the system and keep it cool and quiet, and basically 1/10 of the existing acoustics that we ship today.
Okay, but listen, no technology is perfect.
True.
First, let's talk about the advantages versus a traditional fan.
Yep.
What are the advantages of this system versus a traditional fan?
So the advantages right now are form factor and acoustics, right? So you can basically break the mold with the traditional fan where you have symmetric dimensions. So if I have a 60 by 60 fan, that is the exact same X and Y dimensions. This technology allows me to break that. So I can go to, say, 12 by 50, where before the 60 by 60 you had to have a dedicated cutout in the motherboard. This technology breaks that mold. So before, when you see this technology, basically the PCB boards would have to use bridge connectors and I/O to the left and right. So when you want to plug in your HDMI cord or your USB cable, you have to port that over. because of the cutout of the fan. Now we don't necessarily have to do that. So the advantages are form factor, acoustic, size, but obviously there's challenges as well that comes with it.
Yeah, okay. So tell me some of these challenges.
Yep. It's a new technology, right? So going from basically physics to real product takes time. And this proof of concept was to show what we could do in a form factor such as that 15 watt class product. Now, core challenges, reliability is one. It is a new technology. You mentioned fans. Fans are 100 years old. There's
Everyone
lots
knows
of
about
time,
fans, yeah.
how the fan works, how the bearing fails, fan speeds, motors, all that's well known. This is using basically ions. You have a wire. That wire, you apply high voltage, you're stripping an electron from the air molecule, and then you're basically dragging that to the ground through the electrical field.
Okay.
That is all new physics as far as in a PC.
Right, yeah,
Right?
yeah.
And so you can think about this, static electricity, you're in your house, you're putting your feet on the carpet, you touch a doorknob and create a shock.
Yeah.
That's one way this can fail, it's arcing. And so ensuring that we design the system appropriately for the failure mechanisms with this type of air mover. So great advantages, there are some key challenges, that's one. Power consumption similar, so if you look at power consumption today on our fans, it's about 2 watts in this product. The ICE devices themselves are about 1.8, but there is a high voltage power supply.
Okay.
And so that adds a little bit of power that you have to manage.
Okay.
But volume-wise, it's about a 20% reduction, so I can use that to grow the battery. Do I grow the motherboard? Do I need more memory? It gives me the ability to add stuff back in the box that our customers value.
Yeah, more space, right?
Yep.
Well, or you make it thinner,
Yep.
you make it lighter.
Yep,
potentially.
XY dimension.
Yeah.
You can pick whatever one you want to start to squeeze.
Okay.
The other core challenge is pressure head.
Okay.
So we talked about in our previous videos, the
Yeah.
air moving and the resistance to air. These have a much lower pressure head than a traditional fan. So it's running low velocity. We talked about this in previous video as well. Velocity squares pressure.
Yeah.
Because it's low pressure, you have to be very intelligent on the system design. So the foot height, the venting, the exhaust pathways are all critical. So the system design becomes just as important as the device itself.
Okay, so that's why you're having to partner with them
Yep.
to really dig deep and kind of like
That's
make a new
right.
design, test it out, see how it works.
Yep, and I think there was probably a total of 12 high-powered engineers between the three companies all working together to get the proof of concept built where we could illustrate the technology.
Okay, but it's just a proof of concept
It's-
now.
it's
No
just a
plans of
proof-
release.
No plans to release. It was to get the technology to a point that says, okay, is this feasible for Dell customers? Because at Dell, our reliability requirements are extremely strenuous.
Okay.
All right. We derate every single component on a motherboard. So if you go to the motherboard, all of them get thermocoupled or an IR image. And if you have a capacitor that's say 2,000 hours at 90 Celsius, we have to derate that to live for like 7 years.
Okay.
So we may run that capacitor at 60 C max. So everything is designed to cool it to that requirement. So this similar would have to meet all of Dell's rugged reliability requirements to sell to our large corporate customers, to sell those customers. Ozone's another one, right? So
Okay.
the electrode, because it's pulling an electron off, can create ozone. There's a special catalyst from Ventiva, it's their technology, that basically absorbs ozone to get rid of it from the system and create clean O2 air as it's coming out. And so that's another key challenge. So reliability and ozone, those are some of the additional hurdles we've got to get over. But this was a massive undertaking, and very rarely do you see a proof of concept to this level that's full performance on that Lunar Lake product.
Okay, yeah, so this laptop's Lunar Lake, but
Yep.
what about Arrow Lake HX? Like, how far can it scale?
Well, the technology is very modular, and if you look at it, it makes sense because you're getting between 0.3 to 0.4 CFM per device. If I took like an Alienware class of product, that's
Yeah.
12 CFM, 10 CFM,
Okay.
right? Let's just use that number. It would be 30 devices. That doesn't make sense. And so scaling up to the hundreds of watts, no. 40, that's stretching it. For us at Dell with our spec and requirements, I think that 15 to 25 watt makes a lot of sense.
Could you see a system where you have actually both solutions in there, a fan and this?
That's a great question, potentially. I think we're at the edge of the technology spectrum of where this is coming out, and really getting it to this point. It wants to be independent, it wants to be without an additional fan, but I think
Okay.
when you start bridging that class, does 40 watts make sense between the bridge? Possibly. And I think that's where, the OEMs and the technologies of the world are going to have to choose. Where does it make sense and where do we go? And so we've been doing a ton of work as far as investing in the technology. What are the limitations? And that's some of the core advantages that we've had. And really, I've got to celebrate Intel and Ventiva. There was a ton of hours put in between the companies really to get it to a point where now it may be feasible, and we're trying to get it over the hump.
Okay, yeah, no, it's super interesting technology. Like I love this kind of stuff. Last question I have though, like, is this going to make my laptop more expensive? Is there an inherent cost in this whole new bleeding edge technology?
I mean, usually new technology does cost something.
Right. But maybe you get the benefit from it?
You would. I mean, the benefit today would be 1/10 the acoustics, right, within the same form factor. Smaller, thinner, lighter, bigger battery.
Do you think your customers would have that trade-off? Hey, it's going to be more expensive.
Dell's goal is to not make them make that decision,
Okay,
right? We
okay.
would love to have similar costs to what we're shipping today in a premium product with that capability. I think it's early. We don't know yet, right? Because the catalysts, all the technology challenges, what is that really going to cost? And we get in there, what is reliability required to hit a 5 to 7 year life? Does that cost something else? I think that's really the next step. But when we ship it, if we ship it, it'll meet our cost requirements, our reliability requirements, and it will be at a Dell quality of what we would expect.
Okay, and real quickly before we go, can you talk about the reliability requirements a little bit? Like, what kind of testing are you doing on this system to say, hey, you know what, this is not only going to last, a year, it's going to last 5 years, maybe 10 years.
So highly accelerated life testing is usually what they use as a term to determine, hey, I want to simulate 6 months of very strenuous testing that equates to, say, 5 to 7 years.
Oh, okay.
And so you run it at say, 60 Celsius for 6 months, and you drop it to 0 Celsius once every 10 minutes, right? Those type of profiles is what we use to accelerate the life of the product. But we'll do dust testing, it would be the halt testing, fault testing, ozone testing. All of that capability would be required, and that's really with our partners. They'll be doing that testing as well.
And so that's very common.
Yeah, like most of our products, I don't think most people know this, but most of every single Dell product is tested to 40 cm, right? So we do that to test for elevation. So we can't, if I'm at sea level, I can't run it at X thousand feet. So we actually run the temperature higher to simulate that elevated environment.
Interesting.
And so that's a lot of advantage. We don't talk about this enough, in my opinion, that all the work that we do is just standard process at Dell, but really when you're buying it, you're getting all those components tested to that temperature. And so this would have to meet those same requirements. And so for us, this is the proof of concept. I'm not saying it's a product, but it's a very, very refined proof of concept to illustrate the technology's capabilities.
Okay. Awesome. Well, yeah, it's exciting stuff. Thank you so much for taking the time to talk with me about it. Thank you guys for watching. Be sure to subscribe here on PC World for more PC hardware coverage.